from this video we'll start learning about Linux system programming. So speaking of systems programming, the whole idea of systems programming is basically building utilities over the kernel, okay, the operating system kernel. So speaking of utilities, so what are the kind of utilities that we use in our day-to-day life when we are learning Linux or using Linux? So say you have a utility or say ls, so it gives you the list of files or directories in a certain this thing, or any other kind of utilities that you might use in Linux or maybe in Windows as well. So these are kind of systems programs, okay. So the utility will directly interact with the Linux kernel or a Windows kernel, just for that matter. So this video series will be predominantly focused only on Linux system programming, okay. So speaking of systems programs, so we'll get started with a very trivial functions, okay, that we use in our day-to-day programming activities, okay. We'll be using C programming for this thing. Apart from C programming, you can use a blend of shell scripting and C programming both, okay. So you can choose your this thing. So speaking of the utility that we'll be making today, so what we are going to learn is how we can make a simple version of say printf, okay. So like we'll not be building a complete this thing, okay. So this will serve like a hello world for Linux system programming. So I'll just name it hello.c. So breaking the norm, we'll be not using the STDIO.h over here. Instead what we'll be using is unistd, okay. So why unistd? Because it is the unique standard, or you could say it has all the definitions of all the system calls that are POSIX compliant basically, okay. So here I've opened up a man page of this thing. So here you can see, so the idea is this will emulate what we do in printf, as well as we'll be doing the scanf part as well. So it will not emulate the complete thing. So we will just, instead of using printf functions, what we'll be using is unistd, that is the unique standard. In that we have certain system calls, so we'll be using those system calls to interact, okay. So how those system calls are used, that we'll be studying in these videos, okay. So initially I want you guys to see this. So there are three types of streams basically, okay. So one is STDIN, STDOUT, second one is, and third one is STD error, okay. So these streams have a numerical identity associated with it, which is called a handle usually, okay. So 1, 0, 1, 2 are the handles of this thing, and these are, you could say, enumerated constant values that are given for the streams, okay, or the numerical representations or the character representation, sorry, for these things. So let's get started, okay. So very simple program. So here we'll not be using any printf or anything, we'll be simply using int main, like just to create the program, basic program. We'll do a return 0, and now what we'll do is we'll write our string, whatever we want to display the message, okay. So hello world, okay, and /n semicolon. Now like I said, we will not be using printf. Instead of that we will be using write system call, okay. So what we have to do with this write system call is, first we have to provide the file descriptor, okay. So this is the file descriptor or the handle that I was talking about. So here, as we are going to output this thing into the console, we'll write stdout file no. See here, hash define is the file no 1, okay. Second is the buffer, that is the actual message that we want to send. So this is the buffer, and third one is the size of the buffer. Okay, so for that thing we will count this thing. Okay, so this is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay, so \n is a single character. Okay, so we have 15 characters over here, so this will save. Okay, and we'll just compile this thing just like any other program which we usually do. And hello, sorry, .c. Okay, so here you can see the executable has been already created. So if we write hello, see here we got the output. Instead of using printf, we wrote write over here. Okay, so this was about printing to the console, or you could say STDOUT. Similar way we could use for STDIN as well. Okay, so for STDIN, along with STDIN, what you want to do is you want to read that call. Okay, so in this one we wrote, so that is why we use the write system call, and when we'll be reading in STDIN, there we'll be using the read system call. Okay, so let's just modify the same program. Okay, so let's just remove this message. Yeah. Okay, so character buffer will take. Okay, so let's just say 100 characters buffer will create. Okay, this will be for the input string that we'll be taking. Okay, so we'll just remove this part, extra parts, and apart from that we'll be taking two strings. Okay, one string will be like we'll be prompting the user. Okay, let's make them const. Okay, so why we make them const, I will tell you in some other video. Okay, so here we'll write this thing, enter your name, sorry, enter your name. Okay, and semicolon. Okay, so this will be prompting the user, okay, to enter his name. Another constant character string will take str2, and here I will write hello, hello with the space as a suffix. Okay, and after that what I will do is I will do the write system call, and firstly I will output this string which is enter your name. Okay, so we'll take a person's name and we'll be doing a hello to that person. So this is a very plain and simple program. Okay, it's just to get started with the system programming task. Okay, in the upcoming videos we'll be doing complex tasks related to system scheduling, IPC, and all those things. Okay, so as a head start we'll be doing simple things like this. Okay, so again stdout, hello, and now again the message str1 here, and now we'll count this thing again. Okay, sorry, 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Okay, so 16. Okay, so length we have to give over here. So yeah, after that what we'll do is s size underscore t and bytes read. Okay, so whenever we are taking an input, this read system call, it returns this s size underscore t, that tells us how many bytes it has read. Okay, stdin I will take in this place. Okay, to read n bytes, it is showing you this thing, so it reads, and -1 for errors or 0 for end of file. Okay, so again, so now what I'm going to do is here I'm going to do size of, sorry, size of, okay, and 1 second, let me just buffer -1. Okay, sorry, second one was buffer, I messed up something. Yeah, okay, so first parameter is the file number, second one is the buffer and the size of that buffer. Okay, so once this is done, what we'll do is we'll check whether we have actually read something or not. Okay, so here when you read something, okay, so the bytes read will be more than 0. Okay, so that is why we are comparing with 0. Like if it is greater than 0 only, then this part will be called. And now secondly, whenever you give any kind of user input, after you are finished with your input, you will be pressing enter. Okay, so after you press the enter, so in the string we do not store the \n character, which is the new line character. Instead of that, what we use is a terminator character, or the delimiter, you can say, sort of, which is \0 to terminate the string. Okay, so for that, now I have things in buffer. Okay, so here I will take the bytes read -1, and the last character, what I will be doing is I'll be doing \0, which will be the terminating character. Okay, so once this is done, so like here there are like 2 steps that we have followed extra. Okay, and now what I want to do is I have taken, like, initially what I have written is this string I have printed, like enter your name. Okay, after that we take a user input in this read call. Okay, and now after we have received the user input, what we do is we print this hello along with the name that he has entered. Okay, so in this case we'll have to do multiple calls. We'll not be able to do this in a single call. Okay, I guess we can do it in a single call, that's not a problem, but we want to make it simple. Okay, for now, so again STDOUT, then again this thing str2, which is hello, and the length, which is 5. Okay, 5 characters I have taken, hello and a space, 5 characters. Okay, after that this will be our main string that we'll be using, stdout file name, and the string which we have taken as the input buffer. Okay, and after that we will take bytes read, like to denote the number of bytes that it has read. Okay, that is the size, the last parameter, like how much data is to be written. Okay, and after that we'll again call write to add a \n or a new line. Okay, so whole thing could be done in a single line itself if we concatenate all the character strings. Okay, and we give a total length, but as we want to keep the complexity of the program very low, we are not doing that. Okay, so again now we'll have to recompile this program. Okay, so I've recompiled and no errors as such. Okay, and hello, and let's just see what happens. Enter your name, ABC, hello ABC. So here it has taken hello only. Okay, so it has directly written this name. Okay, so the space character is not considered over here. So why it is not considered? Okay, so that we'll see in the next video. Okay, so till then I guess this should be enough of a presentation. So for the next videos we'll be getting started with the actual, you could say, the systems programming part. We'll be starting with the process or the inter-process communication part. Okay, in terms of Linux based operating system, and then slowly we proceed towards signals and interrupts and all those things, and hopefully we'll be finally branching towards kernel programming sort of a thing. Okay, thank you.